here, okay, at the top it says congruence transformations. Now, if you didn't know this, there's different types of transformations. There's congruence transformations that leave it the exact same shape and size, but it just kind of moves it around. And then there's non-congruence, right, where it makes it a little bigger or smaller. You might call that similarity if you want to, okay? So let's talk about the rules of transformation. First thing we need to know is this vocab, okay? So right underneath the word vocabulary, we got this word pre-image, okay? So whenever we have a transformation, we have a starting point and an ending point. So the pre-image is where we start, and the image is where we end. Okay, so it's kind of makes sense. So we have a starting, we have an ending. So start at the pre-image, end at the image, right? So what I did here is I drew a triangle, which we'll get to that in a minute. But here's what I'm going to do, a little different than the other classes. First thing we're going to write down is all the rules, okay? We get all the rules down, you might be like, oh, duh, and you might be able to kind of finish yourself, which is fine. But let's write it down, all these rules, okay? So, if I'm going to reflect across the x-axis, the rule is x, comma, negative y. Okay, you can write that down. Reflection across the y-axis, I'm going to write all these down real quick, and I'll explain it in a minute. Negative x, comma y. Y, comma x. Negative y, comma x. Negative x, comma, negative y. Y, comma, negative x. And then at the bottom, x plus a, y plus b. Okay, thank you. All right, so I'll give you a second. Make sure you get those down. Those are all of our rules for 3 different types of transformations. So the first 3, notice they all say reflection. There's 3 ways to reflect. Okay? It can be across the x, which is kind of vertically. There's across the y, which is horizontally. The only other direction is kind of not either of those. It's kind of diagonally across y equals x, like it said right there. Then the next 3, we have different rotations. And does everyone know clockwise and counterclockwise? So on the old school clock up here. So if you're going to the left, counterclockwise. So you got 90 degrees, 180, 270. Those are your 3 rotations. And then last but not least, we have translation, which shifts it over up, down, left, right, right? So here's what we're going to do. I drew this little triangle, and we're going to use this triangle. We're going to try these examples. I'm going to show you how to do it from the coordinates, okay? We're going to be writing today. It's going to be kind of small. So, bear with me. I know it's going to be kind of small. You might need to write a little small, okay? So, at the top here, I'm going to write pre-image. Okay? So I'm going to have A, B, and C. So I need to know what is the coordinates of A. So this is negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive 2. So I'm going to put negative 9, comma 2. So that's A. And then B is going to be one more over. So 1, 2, 3, 4, 5, 6, negative 7, comma 4. And then for letter C, we have negative 7, comma 1. Okay, sorry. Boom. Okay, so that's our pre-image. We have 3 points. Now, every one of these transformations, we're going to have a new set of 3 points. It's a lot of writing. It's going to be all right, though. We got to learn the rules, okay? So, if you got your points written down correctly, now we're going to use these rules to write the new 3 points and then plot them, okay? So my first one I'm going to do, the reflecting across the x-axis. We'll go blue for that one. All right, so it says x comma negative y. Notice, the only thing that changes is the y has a negative sign, which means the sign is going to change. Whatever it is, changes. So look at my first letter A. I had negative 9, positive 2. Instead, it's going to be negative 9, negative 2. Okay? So write small. Okay? So I'm going to write this over here off to the side here. Negative 9, negative 2. That's my first point of my reflection. Okay? Now my B is negative 7, positive 4. That positive 4 becomes negative 4. So negative 7, negative 4. The only thing you're changing is the y. See how the x doesn't have a negative in front of it? So your x stays the same, but your y changes. That's the only change. And then for negative 7, positive 1, the positive 1 becomes negative 1. Okay? So all your x's are the same, but your y's have all changed signs. And now we want to plot those 3 points. It should look like it reflected across the x-axis. So, negative 9, negative 2. Negative 7, negative 4, negative 7, negative 1. Okay? So those 3 points should look reflected across this x-axis. Okay? So, we have our pre-image, we have our new blue image that we got from reflecting across the x-axis. All we did was change the y sign. Now, we're going to go back to the pre-image. Now we're starting at red yet again, and now we're going to reflect across the y-axis. What's the change here? The x sign changes, but the y does not change. So we go back up to the red numbers, way up here. Okay, I'm going to use green this time. Okay, so for green, so negative 9, 2. That x value becomes what? Positive 9, and the 2 stays the same. So, positive 9, 2. So negative 7 becomes positive 7, 4. And then negative 7, 1 becomes positive 7. The 1 stays the same. So do you see how we're using the rule to get the points? And now we graph them. So 9, comma 2. 9, 2, put a point. 7, 4, and 7, 1. So if you connect those, you can see that triangle reflected across that vertical y-axis, right? Make sure you're writing small because we're doing 3 for each of these. See how I'm fitting it in? So again, write kind of small. Okay, now this next one says reflection across the line y equals x. Now we're going to take a quick reminder about Algebra 1. So if you're looking at me, you may have seen something like this before. So y equals mx plus b. If you just see y equals x, that means m is 1 and b is 0. Okay? So if I have a slope of 1, that means up 1, right 1. Up 1, right 1. Starting at 0, 0, which is called the origin. Yeah. So basically, this diagonal line that I'm creating right here, that's what I'm going to reflect across. Okay, this is y equals x. So that one might be harder to just like guess at. I know some people are like, I don't like these numbers. I just want to draw it. But I don't want you to get it a little bit wrong. I want you to get it all right. So I want you to look at the rule here. XY becomes YX. So what changed? The order. Very good. It switched the order, and now it'll give us our reflection across Y equals X, right? So let's do that. Instead of -9, +2, switch them, what do I get? 2, -9. So let's write that down right here. -7, 4 becomes 4, -7, and then -7, 1. 1, -7 is right. And once you got those 3 points, plot them, okay, and it'll look reflected. So, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, -9, 4, -7, and then 1, -7, okay? All right? So, mine kind of looks ugly, but you see how it is. It definitely reflected across that diagonal line. So everyone to be very careful when you're reading your problems. There's a difference between x-axis, y-axis, and y equals x. Okay? But those are my 3 reflection possible transformations. Okay? So the next 3, we're going to do some rotations. So let me grab a new color here. Go orange. All right. So this is where it gets a little bit more complicated. You got 2 things to do for each of these, right? So on the first one, 90 degrees counterclockwise, going left, you're rotating from the origin, okay? It says xy becomes -yx. So what happened to y? The sign changed, and then notice where they are. They switch places. So if I were you, I'd first change the y and then switch them. So let me look at A. My y value is +2. What will that become? -2 and switch them. Okay? So if I take -9 and now -2 and switch them, I get -2, -9. Okay? These are one of the more challenging ones, but y'all can do it, of course. It just takes 2 steps. Okay? So -2, -9. So -7, -4. That 4 becomes negative. Switch them. So yeah, -4, -7. And then -7, +1. The +1 becomes negative, and we switch the order, so it's -7, -1. Okay? And like before, let's plot those new points and see that rotation. So -2, -9, -4, -7, -1, -7. Okay. Oops, hold on. I got my counting off here. -2, 1, 2, 3, 4, 5, 6, 7. Sorry. My bad. So 180 degree counterclockwise. Now this one, xy turns into -x, -y. The x and the y are in the same place, but the 2 changes are going to be each one has a negative, which means they're both changing the sign, right? 2 sign changes. So we can do that for sure. Okay, here we go. So -9, +2. Change both signs. What's that going to be? Okay, 9, -2. And then again, negative 7, positive 4 becomes positive 7, negative 4. And negative 7, positive 1 becomes positive 7, negative 1. Okay? So I plot that. 9, negative 2, 7, negative 4, 7, negative 1. Okay? And then, last but not least, 270 degrees. This is kind of like 90 degrees. You're going to switch them, but the x changes this time. So, let's see here. All right, so let's change my x first of all. If I had a negative 9 for my x, that becomes positive 9, and then I switch them. So what would my new numbers be? 2, positive 9. Very good. And then the negative 7 becomes positive, and I switch them. So it's 4, 7. And then on the last one, the 7 becomes positive, and I switch 1, 7. And let's plot those points. 2, 2, 9. 4, 7, 1, 7. Okay. So you can see that's 270 degrees counterclockwise. And then we have one more transformation, and that's translation. Now, translation doesn't have one rule. It just depends what they tell you to do. Okay, so I'm going to give you just an example that we can work with here. And we'll do this one in, let's see here, brownish. All right. Here we go. So let's say you had an example where they said you're going to shift, let's say, right 3 and down 2. Could you take all 3 of those points of the original pre-image red triangle and move them right 3, down 2? I think you can, right? Sometimes you'll see it like this. X plus 3, y minus 2. The main thing people get confused on, don't get confused. You know, everyone knows right is positive, left is negative, up is positive, down is negative, right? So, let's do that. X plus 3, y minus 2, so right 3, down 2, there it is. Right 3, down 2, right 3, down 2. Okay. So that's an example of a translation, right? I could rewrite those points, right? 6, 0, 4, 2, and then 4, negative 1. Okay, you could give me the new points, right, for that translation, okay? But you, at this point, have all the tools necessary to do all the reflections, all the rotations, and any translation that it might give you, okay? Now, there's some examples in the back, so if you look at the back, number 1, reflection. Number 2, rotation. Number 3, translation. And then number 4, another reflection, but it's that fancy one across the diagonal line, y equals x, okay? So what you want to do is, on this right here, find the original points, and then over here, these little tick marks for prime, that's what I would say, E prime, P prime, R prime, N prime. You can find these new points by applying the rules from the front side. And I'll leave it on the board so you can just kind of take a glance at it so you don't have to keep flipping over, okay? But I want you to try these examples as much as you can today. Tomorrow we'll make sure we finish them off before we get some practice, okay? So, going back to the front, I want you to get started trying those out. All right, trying this again. Sorry. We are going to reflect this across the x-axis, and I just did this using the wrong rule. So the x-axis is x negative y. There is no flipping on this. So again, we're going to write this rule, x negative y. And we're going to write all our points. Alright, so there's no switching. There's only changing the sign of the y. Okay, so again, x is normally where it is, but y has a little negative sign right here. Okay, so let's do that. All I'm going to do is change the y values. For e, 2, 1 becomes 2, negative 1. For p, 1, 0, the 0 does not change. And then for r, 1, negative 1, the y value, instead of being negative, is positive. And then for m, for negative 4, instead of negative, that negative 4 becomes a positive 4. So if you can plot all 4 of those points, you will get a figure that is reflected across the x-axis. Okay. Now number 2 is different because 2 you will have to do 2 changes. This says to rotate 90. So we go back and we see rotate 90 is right there. So this rule is negative y comma x. So I'm going to write that rule, negative y comma x. So notice there is a switching of x and y after you change the sign of the y. So let's do that. First thing I want to do is actually write my points. So b is 1, 0. Okay, d is 0, negative 3. X is 4, negative 1. Alright, and then I'm going to take all those. I'm going to change the y and flip them. So on b, the y is 0. That doesn't change. When I flip the order, I get 0, 1. For letter D, 0, negative 3, that y value, negative 3, becomes positive. And then I switch the order to get 3, 0. Notice the 2 changes I did. And then for x, 4, negative 1 becomes 1, 4. We plot these 3 points. And you can see I get a triangle that has been rotated 90 degrees counterclockwise, going, as one would say, to the left. Okay. Alright, number 3 says translate it. It's kind of hard to see this, but it says to translate the quadrilateral 1 unit left and 4 units down. So if I was going to write a rule for this, 1 to the left means minus 1, because left is negative, and then 4 units down means minus 4, because down is negative. Sometimes you're going to have positives where you'll have to add, so right or up would be positive. But let's write our points first. So we got negative 3, 3 for A. Negative 3, 5 for K. Negative 1, 5 for M. 0, 2 for D. And what I'm going to do is I'm going to take all those numbers and I'm going to do the change. So the x's are going to be subtracting 1 and the y's are going to be subtracting 4. So for letter A, negative 3 minus 1, negative 4. 3 minus 4, negative 1. For K, negative 3 minus 1, negative 4. 5 minus 4 is 1. Negative 1 minus 1 is negative 2. 5 minus 4 is 1. 0 minus 1 is negative 1. And then 2 minus 4 is negative 2. So that was a lot of mental math of adding and subtracting positive and negative numbers, which can be kind of confusing. Another way you can do it is just by literally going to your graph and going left 1 and then down 4. That also works. Okay. The only problem with that is that you're going to have to give me the coordinates after that. So you still got to know your coordinates. Okay. But you can see we end up with the same figure shifted left 1 and down 4. It should look correct. Last but not least, we got number 4. We want to reflect over y equals x. If you go to the front of your notes, again, we're not talking about x-axis, we're not talking about y-axis, we're talking about y equals x. It's a diagonal line like you see over here. Y equals x. So my rule is y comma x. So let's write that down. Y comma x. All that happens is that they switch. So first I'm going to write down my points. Negative 4, 2 for h. 0, 3 for n. 2, 2 for v. And then negative 3, 0 for q. I'm going to use my rule. But I want you to notice, all we're doing is switching x and y. xy becomes yx. Just flip. So h, negative 4 and 2, if I switch those, I get 2, negative 4. 0, 3 becomes 3, 0. 2, 2 is still 2, 2. I ain't talking about no ballet. LOL. Negative 3, 0 becomes 0, negative 3. And then plot your points. Remember, y equals x is a diagonal line going through the origin up 1 over 1. So this is what I'm going to be reflecting across. So 2, negative 4, 3, 0, 2, 2, 0, negative 3 gives me the same shape reflected off that diagonal line. And those are 4 examples of transformations that you're doing on the assignment. Show me you can do that.